Welcome to the bytecode. I'm Shafu, and today's episode is with Andrey, who wrote whatsabi, which extracts the ABI from EVM bytecode, even if you don't have the source code. So, very interesting stuff, Andrey. Thanks for taking the time, man.
Hello, thanks for having me.
Yeah, so why don't we start by doing a brief introduction what's ABI is, and then a quick demo, and then a code walkthrough.
Sounds good. Yeah, so what's ABI? We've all used, for example, Etherscan when you go to interact with some kind of contract. If it's verified, you get a little UI on the side. If it's not verified, you get nothing, which is a little bit annoying. And one of the goals of what's ABI is to enable these generative interfaces to work with all contracts, even if they're unverified. So it's on GitHub. What's ABI under my name. My online handle is Chazo. And basically what it does, you give it any EVM bytecode and it extracts all the selectors from that. And then we can look those up against a database and see if they've been registered, if they've been used anywhere, and we can map those back. And then it's also, I'm starting to do work on deriving the actual input types and output types, but that's not very reliable yet. So we mainly look up the selectors in the database. But then also on top of that, Let's ABI also has a bunch of helpers for looking up signatures. So it can look it up on Etherscan. If it is there, then it will just use that because that's nice and easy and 100% accurate. And it'll look up on like Sourceify and OpenChain, and it'll look up on 4-byte databases. And then the other really cool thing that it does that was added earlier this year, I believe, was it resolves proxy contracts. And this is actually pretty difficult because there's lots of different types out there. And resolving them is really annoying. And even Etherscan doesn't do it well. So as far as I know, whatsabi is the most comprehensive resolver out there today. And then the other thing that's worth noting, it's open source, it's written in TypeScript, it's permissively licensed, so you can use it on whatever you want, you can make money off of it, you can do whatever. The other thing, there's been a few other EVM disassemblers out there, like there's Heimdall, for example, which people have heard of, which is really good, but it takes a very different approach. Heimdall would basically go through every instruction, and every time there's a branch, it'll just iterate through the branch and keep going, and it will basically infinitely expand, and in some edge cases can run out of memory and things like that. Whereas whatsabi has a very different approach where we try to get everything in just one pass, and it limits what we can do, but it makes the amount of work that needs to be done very consistent and very reliable. So it's even if the bytecode is very weird and does some very intense things, whatsabi doesn't care. So it's kind of a different approach that has different trade-offs, but it's very nice for working with consumer applications, especially because you don't want to hang or like blow up your browser and run out of memory type thing. Cool. Any questions so far? How's that sound?
Yeah, I actually have a couple of questions already.
Yeah, hit me.
What do you do for signature clashes, for example?
Yeah, so at the moment, just grab the most used one. So most of these services will return the signatures ordered by how often they're seen on chain. What I would like to do in the future that I haven't implemented yet is, so we have kind of very rudimentary input type derivation. Largely right now, I'm just looking at how big the different inputs are. So is it like in 16 and 256? Like I'm not yet looking at whether what kind of type it is. I'm mostly looking how big it is, and I want to map what we derive from that into the signatures that get returned. So if we can match up how many inputs it has and how big the inputs are, we can be much more reliable in terms of input clashes. But that's not done yet. But in general, in most cases, like we have a whole bunch of users that use whatsabi. There's a nice list here. Even Otterscan is using it now, and almost always it works very reliably. Like I'd say almost 98% of the time. So it's not an issue that you run into super often, but it could definitely happen.
Nice, nice. Yeah, and another question I had is, which already jumps into the implementation a bit. You already mentioned like, okay, let's take bytecode compiled by the Solidity compiler. You have the function selector jump table,
Yeah.
right? But what do you do if, I do some weird bytecode obfuscation stuff?
Right. So yeah, the way whatsabi works, you can definitely bypass it with obfuscation.
Okay,
And I'll show you why. If you want, do you want to dive into that now, or do you want to see some examples first?
let's let's see the examples first.
Yeah, got it. Uh, well, hmm. So okay, so I have this README that has some lovely examples, and I'm just gonna like super quickly. It's you basically can get like any provider. You get any address. You just call whatsabi.autoload with the address, and you get this result. The result is just going to be your ABI. But I can run that in real time. So I have some terminals open here. Let me make this real big. Cool. So I have some examples in here. So I have an autoload example, which really all it does is just it does the autoload thing. It writes some messages with a hook. It injects some environment variables, so my like API keys and stuff if I want to use Etherscan, and then it makes a nice output. So there's a bunch of code here that you don't really need. It just makes the output nicer. And then I'm just gonna run it like this and kind of get the API. In this case, I believe it actually loaded it from Etherscan, so it's kind of cheating. But kind of a cool example. All right, let me give you one more quick one. So this is another app I built. Sorry about that. My entire Chrome, I just crashed my Chrome somehow. That's never happened before. Cool.
That happens.
Yeah. Okay, apparently. All right. Shall we retry again?
Yeah.
Right.
I can edit this. It's all right.
Yeah, let me resume from where I was. I'm just gonna skip that in case it crashes Chrome. All right. Wow. I never had that happen before. That's cool.
The modern web stack is amazing.
Yeah. I just updated all my Chromes and stuff, and maybe there's like a bug in there somewhere. It's like, oh yeah, I'll just update everything right before our call to make sure everything's nice and fresh. Last time I do that. All right. Anyway, cool. Yeah, let's just resume from here, and I'll just mention that my thing crashed, and then we'll just jump into something else. How's that sound?
Yeah. Just continue, man. Sorry.
Okay. All right. We're all good? Okay.
Yeah.
So, all right. So I was gonna demo another app that I built, but maybe I'll do it at the very end because apparently it crashed my browser. Let's do another fun thing. So let's open Etherscan. Let's grab a random block. So this is like a block that was just mined. Let's grab some transactions here. And then I'm just going to look at transactions that interact with an unverified contract. So for example, this one looks like this was a thing. Well, wait, that's transfer. So anything that doesn't have a named method is, there you go. So for example, this, like Etherscan doesn't know what this is because it's an MEV bot doing weird MEV stuff. So I did not try this ahead of time, so this might not work. But let's see how awesome whatsabi is. Also, Etherscan is being slow, so I open a couple of things in a tab, and I'm gonna find another one while that's gone. I think it hasn't indexed those transactions yet. All right. Well, Etherscan's being slow, so I'm just gonna try to grab this address and ignore what Etherscan's gonna show me. And I'm gonna just do the same thing here. I'm just gonna run this on whatsabi and see what I get. All right, I got nothing. So this is not a good example. One other tool that I wrote, which is kind of cool for whatsabi. So when I was trying to debug what contracts are doing, I wrote this thing that dumps all the bytecode, which is kind of fun to look at.
Yeah, and
Uh,
Andrei, this is actually a great
yeah,
example. So obviously the
yeah,
MEV bot is doing some weird bytecode
yeah. So
obfuscation thing, and you couldn't figure
exactly.
out the ABI.
Yeah, a lot of the times it doesn't even have a jump table. It just goes like straight into what it's doing.
Hmm.
And honestly, a lot of my like test cases are using MVB bots, so usually it gives me something, which is kind of fun. Uh, but in this case, it did not work. Let me grab one more for fun. So this one looks like Etherscan doesn't know what it is. Let's see if whatsabi can figure out what it is. Oops. There you go. So yeah, Etherscan doesn't know what it is, but whatsabi knows what it is.
Nice.
So we're able to basically reverse all these function signatures, but then we got a bunch of selectors that we actually don't know what they are still. And this is kind of gives you an idea of what to expect when you go like entirely blank. Um, any questions about this part?
Yes, question.
Yeah.
Is someone working on a Chrome extension that adds what's ABI to Etherscan?
Not to my knowledge. There are a bunch of other block explorers that already use whatsabi.
Hmm.
For example, Autoscan. So I think in the long run, we just will not use Etherscan for these kinds of things.
Okay.
But that is a legitimate question.
Okay.
Uh, so let me walk through the code a little bit, and then we can kind of go back and forth and see why this works and doesn't work. How's that sound?
Awesome.
All right. So I'm gonna high level walk through this assembly code. It's gonna look a little weird, and for people that haven't done a lot of EVM stuff, might be intimidated, but don't worry about it. Just we're gonna get kind of a high level walkthrough. So the meat of it is basically here. This is where I get a string that is a bunch of bytecode, and I just iterate over all the instructions. And the cool thing here is this is just one loop, so I only iterate over the instructions once. I try to aggregate a bunch of information about them as I go, so I keep track of all the jumps. I keep track of when I think I have a new method starting, and so on. Wait, this is actually not it. This is it. Yeah. So yeah. Here, basically, I'm just looping over the instructions. And then the way it works is I have a bunch of heuristics that I've essentially determined through a lot of trial and error. So this is not super robust, but it's remarkably effective. And it does a whole bunch of things here. It doesn't only try to get the jump table. For example, here I'm checking if it's a jump destination. If it is, I'm trying to figure out if it's at the end of a function. I'm saving it. I have a bunch of patterns that I'm looking for like sequences of instructions that look a certain way that indicate certain things. So, for example, so all the selector stuff's near the end. So the selector stuff. So yeah, for example, callable functions usually look like this. So we push where we're jumping to. We push the selector that we want to compare against, and then we do the jump. And this is where I basically do the extraction. And I have all the variances that you kind of see being built by the different compilers. And there's like a bunch of edge cases that we had to cover. This was a really interesting one. So if you have any selectors with zeros in front, a lot of times they'll get optimized out. So for example, if it's all zero, it'll just do an is zero instruction rather than do an equality instruction, and that will actually throw off a lot of disassemblers. So we have a little edge case here for that. So yeah, lots of stuff like that. And this is basically it. Like it's not that long, but there's other things in here as well. For example, resolving proxies is up here as well. So we look for delegate calls, and we try to figure out what kind of proxy it is. If it's one of the proxies that embeds the resolution within the bytecode, we just resolve it in here. If it's something that does it through a memory slot, we do it later. And I'll walk you through the proxy stuff too. Here, let me give you like a super quick proxy taste. Oops, what's proxies? Uh, Essentially, how this works, which is also kind of cool. I have a bunch of known proxies that use predefined slots, and I just look for those if they're known proxies. If they're not known proxies, then I have to do a bunch of other stuff. So we work with like diamonds proxies. We work with Zeppelin proxies, with like all kinds of things, and I'll walk through those a little bit closer later as well. So essentially, the way this works. Let me see if I can show it really quick in the bytecode. So here, for example, we figured these out. Let me do a quick split. Hopefully people can still see. Boop. Yeah, like that. Let me know if this is too small for a screen, but I think it'll be fine. So I can use my little helper. How's that look on your end?
Looks good.
Cool. All right, so I'm gonna do my bytecode dump helper. Actually, let me dump it into Vim. That way I can jump around easily. Cool. So essentially what whatsabi does is it looks for this. So you can see here there's a bunch of selectors. And it's just kind of the same thing over and over and over again. It's just like checking if this hard-coded value is equal to what was in the call data. If it is, it jumps to this offset. If it's not, it duplicates it and it checks it against this and jumps to this offset, and so on and so on and so on. So all of these are essentially jump table selectors. And you can see here, this is a selector we matched that we don't know what about. Some of these we do know about. And then when you jump to you have to convert this from hex into integers, so it won't quite work. Yeah, so it like jumps to here, for example, and then it does a bunch of other stuff. Yeah, so this is very simply how that works. So these kinds of selector tables are very obvious when you kind of know what to look for, and that's kind of what whatsabi does. How does that sound?
Yeah, question.
Yes.
So you do one run over all opcodes.
Yes.
Obviously, this has some constraints, right? This
Yeah.
gets into disassembly, static disassembly, dynamic disassembly, all this stuff. What percentage of contracts currently on mainnet would you say whatsabi with this approach works on?
So for on-chain contracts, it's hard to tell. So from like a user perspective, like from like I built an app that needs an ABI for a thing that a user is going to use, it works like 99% of the time, maybe even more, because
Nice.
a lot of times we already have the ABI register, so you can use a loader, or it's an ERC 721 or ERC 20, so on and so forth. If we don't use like a user-centric thing and we try to kind of go for the more adversarial things, for example, the MEV bots that don't have any kind of jump tables, obviously it's not going to do anything there. There is actually another project that's really cool called EVMO. So this is another person wrote, it does a subset of what whatsabi does, but does a different approach. So EVMO actually implements a very minimal subset of the EVM, and it actually steps through. So essentially, it simulates the EVM, but only does a few hundred gas worth of steps, and then that is enough to kind of traverse the jump table and figure out the jump functions. And the person, so CDump, forget his real name, did a lovely benchmark. For example, he has a bunch of sets that he benchmarked. whatsabi does super well on the like largest 1,000 contractors. I get everything right. The like random 50K, I get some wrong. The like Viper ones, I still have some work to do, as an example. So this might answer what you're asking better.
Nice, Andrew.
Yeah.
This is great. This is fantastic. doing it in linear time, I think it's a great trade-off, right?
Yeah, I can do a lot better. There's still one big thing that we need to do is abstract stack tracing. Most of my misses are essentially when the jump is too deep in the stack. So basically, if you put in a jump offset earlier somewhere in the instructions and then you reference it later by like swapping and like duping and all that kind of stuff, I don't handle that whatsoever at the moment. So I need to do some amount of abstract stack things in order to be able to handle those cases. So basically, there's some subset of jumps that are just like lost for whatsabi, and that's I'm pretty sure that's responsible for like most of my misses.
Mhm.
Yeah.
No, this is great. I didn't expect that. I didn't know it was doing it in linear time,
Yeah.
but hearing it and that it's doing in linear time and having this accuracy, this is pretty cool.
Yeah. Yeah. So I mean, the way VML does it is actually like also very efficient. Like you can see the speeds here are really fast because it only executes very limited number of instructions, but it doesn't always get them. So like sometimes you do need more instructions, and sometimes you need then like unbounded number of instructions. Whereas for whatsabi, like you'll never need an unbounded number of instructions. It's always linear time.
Nice.
Cool. Yeah, so that's how that stuff works. Any questions about the disassembly, or do you want to talk a little bit about the proxies?
Let's look at proxies.
All right, so the proxies are also so one of the themes of whatsabi is I kind of wanted to lean into doing the really ugly things that no one else wants to do, and I think that's one of the reasons why whatsabi is so extremely useful because no one else wants to do these things. So, like really simple example, Gnosis safe as an example. Like there's millions and millions of these instances out there. Resolving them is really useful. Gnosis safe has like I can detect Gnosis safe contracts, and then I can resolve them. And the way you resolve them is pretty simple. The reference is always in the first slot, and then I get the address from that slot, and that's the implementation of the Gnosis safe. So this is like a simple example. There's a bunch of small edge cases where one of the earliest implementations of a proxy worked very similarly, except it uses the second slot for some reason. So I handle that as well. And as long as I can detect these differences reliably, I can resolve them reliably. And so far, this has worked really well. Another example is the EIP 1967 proxies, which is a little more complicated because it has a bunch of selectors that you have to iterate over. So there's like an implementations one. So I basically, what whatsabi does, if it can just look if some of these selectors are there, then it knows that it's probably this kind of proxy and it can resolve it. The other thing is I try to avoid doing high level calls when I can, which is kind of neat because you don't make assumption. Actually, yeah, I'm trying to figure out. It's okay. So there's a few different scenarios. So there's a bunch of proxies where there are no high level functions that you can really do. Because the state is stored inside, it's not accessible from the outside. In that case, I just have to read slots. So I'm doing a lot of slot reading. But in the case that the slot reading is not working because the implementations, someone like slightly modified it. So these are like known slots from the EIP that I use. And if that didn't work, then I do iterate over the actual selectors that have all the information, and then I try to get those. And if that doesn't work, then I give up. But the really cool one is Devon proxies. This is one that I've only ever seen one other place resolve them properly, and that's evm.storage, which is a really cool tool. Your readers might know about, or your listeners. It's like a very impressive transaction analysis tool. I don't know what's a good example. Let me click around and see if I can.
Interesting. Yeah, I didn't know about that one.
Oh, you have to check this. So basically, like it breaks it down at the slot level. It can trace different transactions. It does a lot. It's a really smart team works behind this, but it's not open source and you can't use it as a library. So this is what's so as far as I know, it's like the only one that can reliably do daemon proxies without it being verified, quote unquote. And because daemon proxies, the way they implement it, actually pretty complicated, because there's a bunch of mappings that indirect where the lookups are stored. I have a bunch of notes here. So for example, it has this like daemon storage, which is a mapping from a selector to a facet, and then there's a mapping of there's like a bunch of facets as well, and they can be enabled or disabled. So we have to do all this like really low level iteration through storage slots and read different arrays and mappings. And yeah, this one actually got help from Banteg on Twitter. Oh yeah, they also wrote a kind of half implementation of this as well, and then I kind of wrote a more general version off. So basically, I wrote the original version, they wrote an improved version off of mine, and then I wrote an improved version off of theirs, which is kind of like a really magical interaction that you only really get in open source. Here, let me show you this. This is really cute. So like, I basically wrote a whole bunch of notes of how to do this, and then they kind of came along and they're like, hey, I wrote an implementation from your notes. And I'm like, sweet. And then I looked at it and like, wow, this is awesome. This is exactly what I was trying to do. And then I wrote so they basically wrote this, which is great. Basically like, oh, here's how to resolve the daemon storage. There's a bunch of, so they wrote this in Python, which was not the language I was using, but still useful. And then I kind of had to reverse this into my version, which is also more kind of general. Anyway, so this is kind of like a really wonderful story of just people leveraging open source to just make each other better. I just think it's a really happy ending.
Yeah, that's awesome. That's awesome.
Yeah.
And you created a reference implementation basically, and in the Jupyter notebook as well with all the comments and stuff. It's pretty nice.
Exactly. Yeah, and I hope other like the whole idea of this, because it's MIT licensed, so other people can hopefully use this to make other stuff even better, and that's kind of how we kind of improve everything. We just keep making everything, reusing other people's work, and keep making new and interesting things. Yeah, so proxies. Well, yeah, so let me maybe run through an example. So ZK Sync has a daemon proxy. Let me see if whatsabi can resolve it. Let me throw this in here. So I have another helper here called resolve proxy. And again, most of this is just loading environment stuff. So I have an Ethereum API key, and like I grab the address and selector. So the key is to resolve these proxies. You do actually have to do some assembly to actually grab that it's a proxy, because you're looking for specific storage slots that are referenced in the EVM, and then once you know it's a proxy, you can resolve it. So here I resolve all types of proxies, but I have a separate resolver for the daemon proxy. And of course, if you use the whatsabi.autoload, it'll just do this magically. But yeah, let's see if this works. I haven't tried this in a while. What did I do wrong? All right, I need to update something. Let me try the autoload then. Yeah, so there we go. So you can see it knows that it's a daemon proxy, tries to load all the facets. And then the problem is it still has to do a lot of requests for different storage slots to iterate over the arrays and all that kind of stuff. So it does do a lot of requests, and hopefully I'm not going to run out of API keys. But eventually it'll return all the existing facets. I've been using the ZK Sync deployment as my example reference, but they've been updating it so often that they have so much inactive state in there, and I have to load all of it to check which state is active, which state is not active. So maybe this is not a great live example, but it's kind of my like extreme edge case example that I usually kind of test against. But it's been getting slower and slower over the years as they've been adding more and more stuff to it.
Yeah,
because they've been updating it kind of like every few weeks, or at least every few months for sure. Anyways, we'll let this run. Any question about the proxy stuff?
No.
Cool. Yeah. So it's like not super complicated abstractly. It's just something that is hard to generalize because it's a problem that we clearly have. Like we have these things that everyone uses, but they're not a standard. It's not a single standard. Like it's not like a native EVM thing. Like you have some kind of proxy. There's lots of different ways to do it. Like you can, um, yeah. So the only way to solve this, which is a real kind of usability issue, is just to have all the implementations out there and just kind of check through them and kind of try to generalize as much as you can. But there's some weird edge cases that you just simply can't generalize. So you have to have all these different edge cases for them. Yeah, and this is my kind of contribution to our ecosystem, is going through every single one and just working out how to resolve them, which has been super useful. Yeah, so that's proxies. Yeah, let me give you a couple other examples of what else whatsabi does. So there's loaders.
Yeah, one question I have actually.
Yeah.
Viper support.
Yes.
Obviously, Viper does things a little bit different. And we looked at the benchmark a little bit
Yep.
earlier. What's the problem with Viper?
That's a good question. I have honestly not looked super closely into it yet. I need to spend a little bit of time on it. In theory, I've looked at a few examples, and does he seem to work with whatsabi? So there's definitely a lot of cases that do work, but I believe there's probably one or two edge cases that I just haven't covered yet that I have to add. So yes, that is just something that needs to be done.
Okay. Okay.
Cool. All right. So yeah, let me walk through the rest of what else we have here. So we have loaders. In most consumer use cases, this is what gets used 95% of the time. So there's a bunch of default loaders down here. So we have a Dorsify ABI loader. If people haven't heard of it, it's basically like an open version of Etherscan. We have the Etherscan loader. You can bring your like API keys here if you have them. And then we have a bunch of signature lookup loaders. And then I have these abstractions that will try all of them and see if it can load it from any of them. So it has like multi ABI loader and a multi signature lookup loader. And yeah, these are essentially helpers for looking up from pre-existing registries, which is also another kind of example. Like this is a usability issue. Like we have all these different databases that people register their stuff on. It's really annoying to look across all of them. Why should the user even care where it is? This is one of the issues kind of that is very central to what whatsabi is trying to resolve, is like I have some address, I want to get the ABI. I don't care how I get it. I don't care if it's registered. I don't care if I have to load some of the VM. I don't care if I have to load all the VM. I don't care if I want to resolve proxies to figure out the actual implementation. I just want the ABI. Like that's all I want. And this is why whatsabi does all of this, because at the end of the day, you have to do all of it in order to kind of resolve the underlying issue. And then, of course, so kind of we have the loaders. Let me see if there's anything else interesting here. I have a bunch of helpers, which are kind of cool. But at the end of the day, if you're going to be interfacing through whatsabi, you're going to be interfacing through this high-level helper that I wrote, which is called autoload, which does everything for you. It'll resolve your like ENS names, which is useful. It'll load the bytecode. It'll disassemble it for you. It'll check if there's any proxies. It'll check which ones they are. It'll resolve all of them. It'll either return the resolved version or it'll return the unresolved version based on what kind of input you give it. It'll use any of the default loaders or any additional loaders that you give it. It'll use the loaders to resolve whatever selectors that we did discover. It just does everything in kind of one big function. So at the end of the day, all you need to call is just the autoload function that kind of looks like this. You just call whatsabi.autoload address, and it has a bunch of hooks. it just kind of does everything at once. So from a user experience perspective, that's just kind of what almost everyone should be using, is basically this. And underneath it does all those other things that are, so there's some other libraries that do some of it. There's no other library that I know that does everything in a single function, which is one of the reasons why this is really useful.
Nice. No, this is a great abstraction. Should we go back to the zk sync proxy thing? Maybe it's
yes. Let's see. Okay, so yeah, exceeded max retry. But
okay.
Yeah, I need to switch. I have a limit on my Infura. I have like a free API key, and it's being dumb. Let me find another daemon proxy real quick if we can do that. Daemon proxy, Ethereum. Let me see if one of these websites has a link to an existing daemon proxy. Feel free to edit this out later if you want.
Yeah, let me look for one as well.
Yeah. See, like, one of these days I want to do some live streams so that people can be like, "Hey, resolve this," and I'm like, "Yeah, let's try it." So actually,
I actually found one, but I think it's the ZK era one you're already using.
let's try a different one. Hang on. Daemon cut.
Daemon proxy address.
Daemon proxy example deployment. I don't know. All right. Well, actually, awesome diamonds. What is that? Let me show you some info.diamonds. Nope, it doesn't work anymore. I was going to show you my other app that previously destroyed my Chrome. Do you want to see if it works?
Yeah, let's risk it.
Actually, here, let me open it in another profile. Maybe that'll be better. I'm going to open it in incognito mode. So it's called this.link. It has a dark mode and light mode. I'm just going to do light mode. And yeah, basically it uses whatsabi. It's kind of an example of what I want more developers to make. I want more generative interfaces. I don't think every deployment should have its own custom front end, especially if we're just deploying the exact same over and over again. Like if it's in the ERC20 or ERC721 or whatever, we don't need to have a separate UI for each one of these. We could just use a generic interface for all of these. And this is kind of an example of what you can do if you generate your own interface on the fly. This is also open source, MIT licensed. It's built in Svelte. Feel free to steal any of this and make money off of it or whatever you want to do. And well, one of the cool things is like you can build a transaction with this, and it gives you a link. So for example, I have a link here that sends me 0.1 Ether, and I can preview the call. Which is gonna like simulate it, and then you can connect your wallet, which I'm in incognito now, and it's gonna be annoying, so I'm not gonna do it. But yeah, the idea is you can write up a random address here. It's gonna look up the ABI using whatsabi, and then we can actually interact with it here. So for example, we can look up the uniswap.eth address and resolve it and get the underlying contract, and we can call something on it. So we can call the delay and see what the delay value is, which is roughly equivalent to going to Etherscan and doing this and then verifying that you're a human, and then doing this and then doing this and then doing this. So it's, as you can see, it's kind of similar but different. And then we can, of course, create a transaction. So for example, say I want to like set admin, and then I can save this link, and I get this link up here, and then I can open this link here, and it has everything kind of already like pre-resolved and like pre-filled, and we can preview it and all that. And it's not going to work because I don't have a wallet connected to it, and I don't have the authorization to do it. Yeah, so this is kind of like an example of that we can build a slightly better experience in Etherscan. The other cool thing we can do that Etherscan can't do, if we do, for example, Seaport, contract, Etherscan. It's a notoriously complicated contract.
Yeah.
It's like, oh, let's fill in the order. So yeah.
Yeah, Chrome doesn't like
All
this.
right, that happened again. All right. Yeah, it doesn't like when I make a bunch of reactive drop downs. Apparently.
You found a Chrome exploit. Nice.
I know, right?
How to
All
crash
right.
Chrome.
Let me do entire screen share. Blah. All right. All right. You know what I'm gonna do?
Hmm.
Nix run. Nix packages Brave. I'm gonna really quick install another browser. I'm gonna run it because I run Nix.
Yeah, just for context, Andrey
Yeah.
broke Chrome for the second time, which is which is really funny. So we're gonna use Brave
Yeah.
now.
Yeah, and I'm using NixOS to just run this on the fly without actually having to install it. Isn't that cool? All right. Back to this. So this time I'm going to crash Brave, and it won't matter. uh, anyway, so yeah, what we're talking about Seaport. Ooh, Brave results are very different. Seaport, I believe the 1.5 version is even more complicated than the previous versions. So yeah, in theory, this will just load it. So this is also using whatsabi. Oh, there we go. And then we can choose one of the like really complicated things, and it gives us a little UI for like adding arrays, and everything is also type checked. So if I put like, for example, a string in here, it'll actually tell me that this is not a uint8. I believe you put like a negative. So that's the one thing. Like, there's a lot of low-hanging fruit that we can do that Etherscan does not do. Let's see, match orders. This is what Etherscan gives us. Like, write a tuple. Have fun. Like, how are you supposed to write this?
That's a really
Whereas here,
good point.
actually, yeah. So here, actually, I can add arrays. I can reduce arrays. Yeah, everything is like, it'll tell me if I have the wrong input. This is not gonna tell me anything. It'll just try to write it and it'll explode. So yeah, so it's like a lot of low-hanging fruit of how we can improve over Etherscan. Like even this is just an example. Like this is obviously, like, it can be made even better if someone actually put some effort into this. But this is more made as like a demonstration of what you should be able to do that we're not even bothering. If there's any other contract that you have that you wanna explore, I'm happy to do that here. And then you can like build this like really crazy transaction, and then you can save it, and then you can send a link to it.
It's all embedded in the URL. Nice.
Yeah, it's all in the URL. I mean, if the URL gets too big, it won't work. But yeah, so this is actually really cool for like DAOs and stuff. Like, someone can build a transaction. So similar to the like Gnosis Safe transaction builder.
Yes.
But there's
Yeah.
I was just gonna, there's exports it to like a giant JSON thing that you have to move around. Whereas this just gives you a link, and it's all in the URL. Yeah, at some point, my aspiration is to also support if the call data is really big, I wanted to upload it to IPFS and just have a little IPFS thing here, and have it loaded. And this is the cool thing about this is it's entirely done in your browser. There's no backend services that are not your just like standard RPC. And if you inject your wallet, so if you like, actually, let me see if Brave will let me connect. No. If you inject your wallet, it'll just use whatever RPCs your like wallet gives you and whatnot, which is really nice from like a privacy perspective. Like if you're being censored or something, like you're like geo-blocked from Uniswap, you can still use something like this to interact with it, and you can run it locally too. It's all open source and all that. Cool. Yeah, and then there's like, yeah, that's kind of it. There's a bunch of other examples of people using whatsabi. Like recently, Otterscan added it. They made a lovely tweet the other day that Twitter won't show me because I'm not logged in. There's a whole like tweet thread here of explaining how to use it.
Nice.
Like Monobase uses it. Yeah, there's a whole bunch of. So this is kind of a similar interface. You can see the code. You can interact with it. It builds a little front end. So this is all using whatsabi as well. Let's see what else. The Rivet uses it from Paradigm, which is a little extension for like dev tooling. It also loads the ABIs. Yeah, so it's kind of used all over the place for various things. I'm hoping to get more people to use it. Basically, anytime you need an ABI and you don't want to worry about how to get it or worry about resolving proxies or anything like that, you could just use whatsabi.
Amazing. Andrew, this was fantastic. I can't believe I
Awesome.
wasn't aware of whatsabi, to be honest with you. Like I hope
Awesome.
this podcast helps with, spreading the word. Just for the listeners, how I found whatsabi was through Fukuri, who I had on like a couple of episodes ago, who built Tevin. And he
Yeah.
was like, I have to have Andrew on the show. He built whatsabi.
Yeah, so his thing is also going to be using whatsabi. The next big release is going to be integrating whatsabi, which is going to be really cool. You'll
Awesome.
be able to basically, at compile time, you'll be able to have an import string, and it'll use whatsabi to load all the ABI stuff on the fly, and it'll just happen magically. It'll be really cool.
Fantastic. This is awesome. Andrew, what's planned next for whatsabi?
So there's a lot of technical things that are important abstractly, but are not urgent from a user perspective. So like basically everyone who's currently using whatsabi, they just want to get the ABI one way or another, and they want to mostly interact with the contracts that their users are using. So that largely means more loaders that are better loaders. So I have a bunch of issues here to add other loaders. There's AnyABI.xyz. There's like a third web that they put verification onto IPFS. I want to add that. But from a technical perspective, the things that we can really improve long term. So one big one is the upcoming upgrade to Ethereum that adds the EOF stuff. So that's going to break a lot of things, unfortunately. Because basically the way the jump tables are declared is going to be different under EOF. So that's something I'm going to have to do eventually before the upgrade, or shortly after the upgrade, if anyone ends up using that. Another idea I had is to create a hybrid, which kind of does the initial linear pass using whatsabi, but then optionally uses EVML to load the input types. So as I mentioned before, EVML is this other approach. The one downside to this approach is you have to do every function separately, because you're simulating the input. So you're simulating a different function call. So if you have like 100 functions, you have to do like 100 different iterations of this, which is not ideal. So I need to figure out an interesting hybrid, because he wrote really good input type extraction stuff that I don't have, and I would like to kind of utilize it as well if I can, but it kind of relies on running this little EVM simulation. Let me see if I can find it real quick. But yeah, so that's one thing I've been thinking about, is how to utilize this work as well. And then yeah, abstract stack tracing is kind of a big one. If I can improve on that, it would be worth it.
Nice.
But that's kind of a big task. So basically, there's a bunch of difficult technical things that need to be done that it's unclear what the end user benefit will be. So I'm kind of trying to balance these two things, where I'm mostly trying to improve the end user benefit. Like I just want the ABI, and I'm this type of user. uh, people that are trying to attack MEV bots are not my main demographic. I don't think it needs to be a JavaScript library to do that. It can be any kind of library. So that's not my main. So I don't really care about if you're trying to like obfuscate. I just want to kind of work for most normal contracts is my main use case. Yeah.
Yeah, awesome. Andrey, listen, this was super interesting. Thanks for building this, man. Like, yeah,
No worries. Yeah. I
as
hope
I've
you'll
said
try to use it
before.
and
No, no, go ahead,
yeah.
go ahead.
I was just gonna say I hope you try to use it and let me know if anything's missing for you, if anything's a little too hard than it should be.
I
Definitely hit me up.
will, I will, I will. Yeah, thanks, Andrea. I'm gonna put the GitHub link, your Twitter in the description down below. Yeah,
Perfect.
Andrea, thanks for taking the time.
Thanks for having me.
Awesome, guys. Thanks for tuning in, and I will see you in the next one. Bye bye.